In today's session, we will try to discuss approaches to knowledge representation. From previous session, we have understood what actually is knowledge representation and what are the different types of knowledge, what are the various components we need to learn if you want to train your intelligent machine properly with your knowledge representation. Also, we have seen what are the components of your knowledge life cycle. So in today's session, let's start with this concept called as what are the various approaches to knowledge representation. So the same concept is discussed in previous session, but unfortunately we were this is not part of your video. Let's again try to summarize these concepts. So there are four approaches basically to represent your knowledge for your intelligent machine. First one is simple relational knowledge, second one is inheritable knowledge, third one inferential knowledge, and fourth one procedural knowledge. Let's quickly start about what actually is simple relational knowledge. So it's actually about, following some structure what we actually learned about different types of data storage in your rdbms. The same manner now we will try to store facts which uses relational method, and uh, each fact about set of object is set out systematically in columns. So this is basically similar to your rdbms or sql what you have learned in the previous session, sorry, previous study. So in the same manner we will try to understand simple relational knowledge with respect to your structured query language. This approach to knowledge representation is famous in database systems where the relationship between different entities is represented. So we'll be having various entities and we'll try to represent how they are related. So this approach has only little opportunity for inferences. Inferences means drawing some conclusions. You'll be, as data is stored in rows and columns, it will be easy to understand, but there are only some opportunities for leading to some conclusion or some inferences. Okay, so this is the example how we represent your simple knowledge representation. So you'll be having some heading or the name or for the given column, and according to that you'll be having some attributes which will be representing different people or some players in this scenario. So this is the simple example for your simple knowledge representation. Okay, yeah. So let's talk about the second approach, that is inheritable knowledge. How we can represent your knowledge by taking into consideration the previous parameter. So this is like the inheritance concept what you have learned in your oops. So you'll be inheriting some concepts, some ideas from the previous approaches. So let's try to understand it with this example what we have seen. uh, so you are having some persons, to different persons like peter and ankit here. So these are the instances for your scenario. So peter is playing cricket and ankit is playing a football. So they are basically both are players, that's why we are pointing it to the same direction, that is players. Cricket, peter is a cricket player, ankit is a football player. And as both are males, they are representing to a common scenario, that is uh, a player here is a adult and is a male. So this is the representation from one instance to other instances using some is a relationship. Likewise you'll be having is a and kind of relationship. So that's how we inherit one object to other object and how they are having some relationship between them. So in this approach we apply inheritance property. You can see the third point here. Elements inherit values from other members of a class. So you are having different members and we are trying to inherit one property from other property through your inheritance concept. So this approach contains inheritable knowledge which shows a relation between instance and a class, and it is called instance relation, that is using your easy relationship. So every individual frame can represent the collection of attributes and its values. So you can see individual frame here is representing some knowledge from one state to other state. Okay, yeah. So we use arrows which point from objects to their values. So here we are using arrows according to the separation between two frames or two objects. So if there is a common object, we are using a single frame, single arrow. You can see here that is a common relationship between players. If there is a if there is no common property, we are using separate arrows, and we are trying to show the inheritance property through your knowledge representation. And the next knowledge approach is inferential knowledge, which represents knowledge in the form of formal logics, what we have seen in the propositional logic and predicate logic. So there we have used the various quantifiers to represent your statements or the premises. So the best thing what we can say about this inferential knowledge is it guarantees correctness. Okay, so here you can see a small example given for two statements, that is Marcus is a man and all men are mortal. So these statements are represented with respect to your predicate logic, that is Marcus is a man using your predicate man, that is the object here, and Marcus is the name representing a man. So for all x is equal to man of x, uh, if mortal is x, that is using your implication rule we are trying to represent symbolically using your inferential knowledge. So we are trying to get some inferences or conclusions using your various quantifier way of representing your knowledge. And the next important one is the procedural knowledge, what we have seen previously with respect to your logic programming. So while learning your logic programming, we have come across the important programming language of your AI, that is Prolog. So in your procedural language, one important rule is used is if then rule. So we'll try to see how if then rule is applied using your programming concepts using in your procedural knowledge. So we can in this procedural knowledge we can use various coding languages such as Lisp language can be used, Prolog language can be used. As I said, Prolog language is basically declarative language, but which can be used in combination of various aspects, and it will be also used as part of your procedural knowledge. So we can easily represent heuristics or domain specific knowledge using your procedural knowledge. So that's all about what are the different approaches with respect to your knowledge representation. And now we'll try to see what are the basic requirements you need to possess to your intelligent machine for knowledge representation. So a knowledge representation system should have these four basic points or the properties to make a system intelligent. First one is representational accuracy. So knowledge representation system should have the ability to represent all kind of required knowledge. That's what we are discussing from the initial session, guys. A knowledge representation should have or should possess knowledge in all the various types of aspects. It's not only about one thing or two things. It need to imbibe the knowledge or emphasize the knowledge from all the different aspects. That's what we call it as representational accuracy. So if a system need to be accurate in giving some decisions, it need to have knowledge from all different types of areas. Why? Because as a user I may be having questions with respect to my understanding of the scenario, but if I talk about other person, his understanding capabilities might be different and the questionnaire might be different. So it need to answer to n number of users, and it need to cover all the points all and it need to have the knowledge in all the different areas. That's what, then only a system can be accurate. That's why the first knowledge what it need to possess is representational accuracy. So it need to be fed with knowledge in all different types of areas to be an accurate machine. So next one is next knowledge what we need to possess is inferential adequacy. So a knowledge representation should have ability to manipulate the representational structures to produce new knowledge corresponding to existing structure. So this can be obtained by taking into consideration the previous experiences or previous scenarios what happened with respect to the same concept. That's what we have discussed in the previous thing, what an intelligent machine should have if it need to give some proper conclusions. So it's not only that every time whatever you are giving that need to be shown as it is, it also need to understand from the past experiences, then only it can be inferentially adequate. It can get knowledge from past systems, and accordingly it can give to lead to some solution. And next property what it need to process is inferential efficiency. So and system need to be accurate, adequate, and also it need to be efficient. So if a knowledge representation system need to be efficient. It need to be able to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guides. So instead of having knowledge of unnecessary contents, it need to collect knowledge or analyze knowledge from the appropriate guides. Then only a knowledge can be properly fed to the machine and it can react accordingly. So then only it can be it can give to some proper conclusions which are efficient. And next one is acquisitional efficiency, that is the ability to acquire the knowledge easily using automatic methods. So because we are going to write an algorithm to develop your intelligent machine, so it need to be provided with all the facilities where it can automatically try to recall the concepts. Suppose if I say if I take an application, for example my mobile, in my mobile I'll be having an noise recognition system or the speech recognition system, where the application is, if I take an iPhone, it is the Siri application or the Google uh, assistant, where it will try to recall the concepts automatically. Suppose if I say call to Ramesh, so it will try to recall the databases and it will try to feed, it will try to see how many contacts are linked to the name called as Ramesh. Suppose if I say I have kept three names: Ramesh friend, Ramesh brother, or Ramesh friend of friend. It will try to ask you a question: which among these three need to be called as per the instructions? That's how it will try to recall all the concepts and it will try to see the how efficient the system can be according to the instructions what you are providing with. That these are the four important requirements for a knowledge representation system to be efficient, accurate, and adequate. So that's how you need to remember about these concepts. Yeah. So now let's talk about next important phase of your knowledge representation, that is techniques to represent knowledge representation. So as part of our syllabus, this is the last concept of your unit 2. So you'll be having four ways of representing your techniques of your knowledge representation. So we need to learn about these four different types of knowledge representation techniques, and with this we'll try to end your unit 2. Okay. So the four different ways to represent your knowledge are: first one is logical representation, second one semantic network representation, third one frame representation, and finally we'll discuss about production rules. So coming to your specific syllabus specific discussion. So in syllabus we are given with semantic network representation and frame representation. These two methods, logical representation and production rules, are not part of our syllabus, but we need to learn all these concepts as part of your unit 2, which actually represent how a knowledge can be transferred to some intelligent machine. Okay. We'll initially now discuss about your logical representation. So basically these are the four different types of knowledge representation what an intelligent machine need to possess if it need to be accurate, efficient, and adequate. So I want everybody of you to note these four different types of representation, because in tomorrow session once I ask you questions based on this, you need to give answers accordingly. Yeah. So now let's talk about logical representation of your knowledge. So these are the things what we have learned as part of your unit 2, uh, in the initial concept of logic programming. So it talks about logical prepositions, like propositions and predicate logic only. So a logic representation is a language which with some concrete rules which deals with propositions and has no ambiguity in representation. So whatever we have discussed as part of your first part of your unit 1 about logic programming, those all things are nothing but your representing your knowledge with respect to logical representation. So, logical representation means drawing conclusion or inferences based on the various conditions. You will be using some semantics, some syntaxes, some rules, some facts, axioms. All these things are part of your logical representation. And finally, we will try to conclude according to the given question. So, this representation lays down some important communication rules. The rules will be framed, and according to the rules, we need to get to some conclusion. Yeah. So it basically consists of precisely defined syntaxes and semantics which supports the sound inferences. So if you are following the proper syntaxes and proper semantics, definitely you can assure some good conclusions or some proper inferences with some exact reasoning. So each sentences can be translated into logics using your syntax and semantics. So with respect to that, syntaxes and semantics, we will be using some symbols, some logical connective statements, we will be using some rules of inferences, whatever we have seen as part of your propositional logic and also predicate logic. Those all things include as part of your logical representation. So talking about your syntaxes, so everybody know what actually is syntax is, or syntax in your programming. Syntax are the rules which decide uh, how we can construct legal sentences in your logic. So we need to understand how to write those symbols, we need to know how to use those symbols according to the given statements or given premises. In the same manner, we can represent your knowledge using your symbols in your knowledge representation. So talking about what are the semantics, semantic are the rules by which we can interpret the sentence in the logic. So given premises, from the given premises we need to understand how this premise can be converted into knowledge using your various connective statements. Semantics also involves assigning a meaning to each sentences. So that's what we have seen in the previous discussion, like Marcus is a man and all men are mortal. So with there we try to understand those two premises, and we have represented them using your quantifiers according to the symbols what we have used. So this is what we are discussing. So when I talk about logical representation, we need to understand about propositional logic and also about predicate logic, what we have discussed as part of the first part of unit 1. Okay, yeah. So what are the advantages and disadvantages with respect to your logical representation? So there will be many advantages with respect to logical representation, but we have taken two important points about the advantages. But first one is it enables us to do logical reasoning. So logically, if you want to give some knowledge representation and reasoning, you need to go for your logical representation, and it is the basis for programming languages like Prolog and Lisp. So what are the disadvantages of logical representation? So logical representations have some restrictions, and it's very challenging to work with that, because you need to be very clear with the logical statements or the symbols what you're using. Sometimes the challenges will be complex, and we need to put a lot of effort to make a programming language understand how a logic can be represented. Okay, yeah. So the second important approach what you need to learn with respect to knowledge representation is semantic network representation, which actually is part of your syllabus, which we need to learn thoroughly about what actually is semantic network representation. So in the name only we can see it is a network which is connected with a number of statement. So basically semantic networks are alternative of predicate logics for knowledge representation. So if you are clear with your predicate logic concept, this is the alternative for your predicate logic, which will be using trying to give solutions for knowledge representation and reasoning with respect to some network. So in semantic networks, we can represent our knowledge in the form of graphical network. I'll just show you some example here how this can be represented using your different connective statement. So we'll discuss about this in the upcoming slides. So here, network consists of nodes which are representing objects, and arcs which describe the relationship between those objects. So basically, we will be having some objects, and those objects can be represented using in a network. And arcs will be representing your basic, that is, the symbols will be representing your various scenarios. Okay, semantic networks are easy to understand and can be easily extended. So it is very easy to understand your semantic networks, but there are still some problems if you want to get some solutions with respect to your semantic network representation. So this representation consists of mainly two types of relations. One is a relationship which we have discussed as part of your inheritance concept, inheritance knowledge in the previous slides. And next one is kind of relationship. So we'll try to understand this in the next slides. Yeah. So basically, summarizing about your semantic network representation, a semantic network is a graphic notation for representing knowledge in patterns of interconnected nodes. So there are different types of nodes with various relationship between them. We need to connect them using your easy type of relation or kind of relation. Accordingly, we need to picturize or your network. So talking about a semantic network with respect to your AI, so it is a popular method in your AI and natural language processing because it represents knowledge or supports proper reasoning. So if you are using your semantic network representation, we can assure that it can give to some proper exact reasoning. So these act as alternate approach for predicate logic in the form of knowledge representation. So these two slides basically give understanding of what actually is your semantic network, and how it is the alternative for predicate logic, and what are the basic types of relations like easy relation and kind of relation what you use. And also we are saying that it is a network with interconnected nodes, and that will be used as part of your AI and natural language processing. So we'll try to take a small example and try to understand what is semantic network representation. So here you are given with five sort of statements. That is, Jerry is a cat. That is, we are saying that Jerry is the name of a cat, and Jerry is a mammal according to the classification of animals. So Jerry is owned by Priya. That is, Priya is the owner of a cat called as Jerry, and we are saying that Jerry is white colored. The color of cat is white in colors, and we are saying that all mammals are animals. That is, cat also is a animal. Now we will try to represent the same sort of statements using your semantic network representation. So this is an example. We are You need to understand about the statements given here. So we are taking some object called as Jerry here. So basically we are talking about a cat. So cat, Jerry is a white colored cat. So from this statement, we can see white is one important thing what I have considered here. That is the color, and Jerry is the name, and cat is a animal here. So I'm saying that Jerry is a white colored cat. That is the representation from these three objects. And I'm saying cat is a mammal, and also cat is a animal, because at the last statement you can say all mammals are animals. So we are saying that cat is a mammal and cat is also a animal. And you can see Jerry is a cat and owned by Priya. That's how we are representing the owner also here. So the set of statements will be given like that, and we need to say how this can be represented and how a knowledge can be represented using your semantic network representation. Okay, I hope this example is clear. Now let's try to see where actually we are going to use your semantic network. What are the applications? So we basically use semantic network for representing some data. As you can see here, some data is being here. We are representing it using your network for a proper understanding. uh, and we also use for revealing your structure like relations, proximity, relative importance with respect to your network representation. So it's also used for supporting conceptual addition. The concept can be clearly picturized as form of a network, and it will be used in a number of aspects. That is, supporting your navigation. If you're talking about your applications of your network, so it will be used in navigation to say which type of directions can be used, like how some different places can be connected using your network type of, like Google Map of applications for your navigation. So, talking about advantages of semantic network, there are many points listed here. The first point is it is simple and easy to understand. Yeah, and it is more natural than your logical representation. So, advantages are given here comparatively with your logical representation. Semantic network can be much more simple to understand and easy to represent. Yeah. So, this can be used as typical connection application in various fields of knowledge like computer science, anthropology. As we have seen now, navigation is one application. That is the advantage of your semantic network. So as a simple approach to investigate the problem space also, because the problems like statements, if I am giving some statements, it is very difficult to understand. But if it is a network of representing your objects, it is very easy to investigate your problem space. So likewise, these are the list of advantages what you can understand about your semantic network. So a semantic network has a greater expressiveness compared to your logic representation. Okay, you all can go through this PPT once I share. All these points are the common applications about your network approach. So, talking about disadvantages or the drawbacks in semantic representation. So, basically, it needs lot of time, and the computational time or runtime is very high, because we need to traverse the complete network to answer some question. So, here you can see, if I say I want to know who is the owner of a cat called as Jerry, it need to traverse to complete a tree or the network, and it need to give some answer. That's the reason, that is one important drawback with respect to your semantic network. So it might be possible in the worst case scenario that after traversing the entire tree, we find the solution does not exist in this network. Suppose if I say, instead of Priya, I'll say that uh, Shaker is the owner of a cat called as Jerry. So if you want to say whether it is a correct answer or not, you need to traverse the complete network, and at the end, the answer will be no. That owner is not Shaker; it is Priya. That's how we. That's the reason. Sometimes the answer might not be correct, and it takes a lot of traversing time. Okay, yeah. So semantic networks are not intelligent. They are dependent on the creator. According to the scenarios, the creator will be giving some input like how to create a network, and because it's not intelligent, it will not try to think about itself. It basically depends on the creator. That is one important drawback of your semantic representation. Okay, there are the different drawbacks what you need to understand with respect to your semantic network representation. And the next concept is about your frame representation, which is also part of our syllabus in unit 2. So once we complete your frame representation, so basically we are done with your unit 2. Okay, so talking about your frame representation of your knowledge. So a frame is a recorded like structure which consists of a collection of attributes and its values to describe an entity in the real world. So we'll be having various attributes, and these all things will be represented as part of your frame. So let's try to understand it with respect to examples in the next slides. So, talking about your frame representation, it consists of collection of slots and slot values. So here we need to understand the terminology about what actually is a slot and what are the slot values. The slots may be of any type and any sizes. So basically, slots have some names and values which are called as facets. Okay. So what actually is a facet is the various aspects of a slot is known as a facet. So whenever a question is asked about what actually is face representation in knowledge representation, you need to give this terminology like what is a slot, what are slot values, what is the facet. So facets are features of frames which enable us to put constraints on the frames. So we'll try to see with respect to an example like what actually we are discussing. So let's take a small example of a frame for a book. If I talk about a book, so what actually is a slot? That is the attribute in your general understanding, and what is the value. So if I take a book will be having a title. It is called as a slot, and the title of a book is the filter or the value what you are representing. That is artificial intelligence. So I'm taking a small book example here. So the gene, the type here, which type of branch is that is your computer science. That is the people who need to use your book is computer science. And who is the author? The author name is Peter Norvig from the book whatever I am representing. So these are called as your slots, and these are the filter or the slot values according to the given input. So basically, a frame may consist of any number of slots. It's not only one or two slots. You can be having even n number of slots, and slot may include any number of facets or the slot values, and facets may have any number of values. So if I say a title here, according to the one book given here, that is the artificial intelligence, the title here. If I talk about the same example with respect to another book, it will be having different type title name. So likewise, it can have a number of values for a given book. So a frame is also known as slot filter knowledge representation in AI. So remember this terminology, guys. It's also called as slot filter. So that's what we have seen here. A frame is also called as slot and filter representation. So I remember this terminology, like what is a slot, what is a facet, what are the values. They contain information of all the attributes present in a given object. So here you can see book is the object here. All the information regarding book is taken into a single frame here. This is the representation of knowledge with respect to your frame representation. So let's take another example with respect to some statement that a paragraph here, like Peter is an engineer as a profession, and his age is 25. He lives in city called London, and the country is England. So likewise, you are giving some statements, sequence of statements, and from that we need to understand what is a frame representation. We need to understand what is a slot, what is a filter. According to that, we need to input some knowledge to your knowledge representation system. Okay, this is about your frame representation. So the frame representation makes the programming easier by grouping the related data. All the important slots will be separated, and it will be easy for a machine to understand clearly what is this, what are the values of your slot. So frame representation is comparatively flexible and used in many applications of AI. Similar to your semantic network representation, frame representation also is used in many applications in your AI. So it is also very easy to add slots for new attribute and relation. So if something is newly added, it is easy to add, and accordingly it can be representation. So as said, frame representation is easy to understand and also easy to visualize your contents. Okay, so finally we'll try to come to the last representation approach, that is production rules. So production rules, basically this is not part of our syllabus, but let's try to understand what actually is this according to the different types of representation. So it consists of a condition and a action pair, which means if condition then action. So that is similar to your implication, that is if then rules. Then it will try to understand what is the condition and what action can be taken. So for that, it is actually having three parts, that is it need to have some set of production rules, some working memory, and it's also called as the recognize act cycle. That's what we have represented here. This complete process is called as recognize and act. That is, the condition will be recognized and accordingly it will be doing some action. Okay, yeah. So in production rules, agent checks for the condition, and if the condition exists, then production rule fires and corresponding action is carried out. It will try to check the condition, accordingly it will try to react to the given scenario. The condition part of the rule determines which rule may be applied to the given problem, and the action part carries out the associated problem solving step. So when I talk about production rules, you need to remember about condition and action. So condition will take the rule and it try to say what can rule can be applied to the problem, and the action will be trying to say how a problem can be solved. So the entire problem here is called as your recognize act cycle. Okay, yeah. So here you can see the working memory contains the description of the current state of problem solving, and the rule can write knowledge to the working memory. So this knowledge match this knowledge, if the knowledge is matched, it will try to fire, that is try to give some solutions according to the knowledge what it is having. Yeah. So if there is a new situation or new problem generate, then multiple production rules will be fired together, and this is called as your conflict set. So whenever you are having some new rule or new problem, multiple rules will be applied, and accordingly it will try to give some solution to the given problem. And in this situation, the agent need to set a rule from the given sets, and then it is called as conflict resolution. Okay, yeah. So here is an example like how we will represent your production rules. As I said, if and then condition. This is a general example about the production rules. So according to the general real world example, the first point here saying that if at bus stop and bus arrives, then action get into the bus, because you are being waiting for a bus in a bus stop. If you are at a bus stop and bus arrives, then the action is you need to get into the bus. Okay. And second rule, you can see, if on the bus, that is, you are entered into the bus and paid and empty seat, you have paid the ticket fare and the seat is empty, then definitely the action is you are sitting down in the on the seat. Likewise, you will be having if and then conditions, and according to that you will be getting your solutions. Okay. So the advantages of production rule are, the production rules are expressed in the natural language, it is easy to understand, and they are highly modular, so we can easily remove, add or modify an individual rule. Okay. So production rules disadvantages are, does not exhibit any learning capabilities. It only try to see what is the if then condition, and it will not store the problem for the future use. That is one drawback of your production rule. And the final step here is, during the execution of the program, many rules may be active. Hence, rule-based production systems are not muchly preferred. They are inefficient. Okay. Yeah. So that's it, guys. With this, we have completed the knowledge representation part. And thank you for your time.